Hello students, today our new topic is characteristics of group. This is part 7, grade 10th chemistry, periodic classification of elements. I hope this is its last part. So coming to our point, that what is groups? We know that in the long form of periodic table, the vertical columns, vertical not horizontal, it's vertical column present in the long form of periodic table, that is called groups. Okay, and there are 18 groups in the long form of periodic table. So coming to our first characteristic, that is valence electron. What is valence electron? The number of electron present in the outermost cell of an atom of a particular element, that is called its valence electron. Simple. And when we go top to bottom in a particular group, then the valence electron of a group is same. Why? Because if we take some example, the group number first, in which lithium, sodium, potassium and rubidium, cesium, francium also involved in it, then the valence electron of lithium is 1. We know that the atomic number of lithium is 3. So in its first cell there are 2 electrons, and in the second cell it has only 1 electron. So in the outermost cell of lithium is only 1 electron, and so on. Sodium has 1 electron also in its outermost cell, and potassium has also 1 electron in its outermost cell. So this is called the valence electron. When we talk about the group number 17, then it has also same number of valence electron, in which fluorine has 7 valence electron, chlorine has also 7. So these are some examples. Throughout we saw that the valence electron of a particular group is same. And the next point is valency. Valency. Next characteristic is valency. What is valency? The number of electron, that it means the number of loss or gain electron, in order to complete its octet and duplet, that is called its valency. In which if we talk about the first group, then we can see that the valency of group 1 is same, that is 1. And if we talk about the group 17, then its valency is 1, because these are non-metal and it has 7 electron present in the outermost cell, and it only gain 1 electron to complete its octet, so it has 1 valency. Okay, so if we talk about group number 2, beryllium, magnesium, calcium, so it has 2 valency, because in its outermost cell there are only 2 electrons, and these are metals. It has a tendency to lose electron, so it can easily lose 2 electrons in order to complete its octet. Okay, so if we talk about the lithium, sodium and potassium, then it simply lose 1 electron, because it is very reactive in nature. So it simply lose 1 electron. It has a valency of 1, and sodium has also valency of 1, and potassium has valency of 1. So the valency of these elements are 1. It can simply lose electron and convert it into Li plus 1 plus, because it loses 1 electron. And sodium has also Na plus, and potassium has also K plus. Okay, but if we talk about the non-metals, that fluorine, chlorine, bromine. So fluorine has 9 atomic number, so 2 and 7. So fluorine has 9. So here it accept, fluorine can accept one electron and form F minus, because it gain electron, not lose. And chlorine has also 2, 8 and 7, because its atomic number is 17. So it can also accept one electron and form Cl minus ion. Here you can also say, see that the metals formed plus charge, plus ions, and non-metals form minus charge, we can say that. Okay, so these are the valencies. If we talk about the next point, that is size of atom. This is its third characteristic, size of atom. When we go in the group, top to bottom in the group, when we go top to bottom in a particular group, then size of atom increases due to, in a group there are number of element that is belongs to the several periods, in which the lithium belongs to period number 2nd, sodium belongs to period number 3rd, potassium belongs to period number 4, and we know that how many numbers of period it has the same number of cells, in which group 1 has one cell, period 1 has one cell, period 2 has 2 cell. And if we talk about some example, lithium, sodium, potassium, so lithium has 2 cells, in which the first cell has 2 electron and the second cell has 1 electron, because it has a it has an atomic number of 3. The next is sodium, it has the valence atomic number is 11. So it has 1 and 2 and 3 cells, because it present in period number 3rd. So on, if the potassium present in period number 4, then it has 4 cells simply. So we can clearly see that when we go top to bottom in a group, then simply the atomic radius is increases, because the number of cells are increases. Okay, and when the number of cells are increases, the atomic size also increases. This is really simple. So this is about the size of atom. And the next is metallic character. If we talk about the metallic character, then metallic character, if we talk about, but here metallic character is little bit different in metals and in non-metals. If we talk about the metals and non-metals, then in metals the metallic character is simply increases when we go top to bottom. In going down in a group of periodic table, the metallic character increases. The metallic character increases. But in non-metals, the metallic character decreases. Because recently we talk about the atomic size. When we go top to bottom, then the atomic size increases. And when the atomic size increases, the tendency to lose electron is increases, because the attraction force between the nucleus and the outermost cell, due to large in size, also increases. And the tendency to lose electron is increases due to increase in size. Why? Because attraction force between nucleus and the outermost cell's electron is the force, attraction force between nucleus and outermost cell's electron is decreases. Attraction force is decreases, due to the distance increases. And when we talk about the loses electron, when we talk about the non-metals, because non-metals simply accept electron, and when it's due to size is increases, the tendency to the tendency to gain electron decreases due to increase in its size. So if we talk about in the first group, lithium, sodium, potassium, rubidium, cesium and francium, the tendency to lose electron increases when we go top to bottom, when we go downward. But when we go downward in non-metals, the size of an atom increases, and due to its increasing in size, the tendency to accept electron decreases. So when we talk about the metallic character in metals is increases, in non-metal is decreases, and the same thing is present in the chemical reactivity. Chemical reactivity. When we talk about the chemical reactivity, then in metals, the chemical reactivity increases. Here the same thing comes again. When we talk about the metals, that when we go downward, the size is increases, we know that, and when the size is increases, its tendency to lose electron also increases due to increase in size, and its reactivity is also increases. It is very related to each and every one, that if the size is increases, then its metallic character is increases, and when the metallic character is increases, the chemical reactivity also increases. Okay. And when we talk about the non-metals, then chemical reactivity is decreases. I recently told you that when we go top to bottom in non-metal, the size is increases, we know that, and when the size is increases, its tendency to accept electron or gain electron also decreases. When the size is increases, then the tendency to gain electron is also decreases due to increasing in size, and hence when its size is increases, its chemical reactivity is also decreases, because tendency to gain electron decreases. So this is about the chemical reactivity. It is related to each and every one, that if the size is increases, then in metals its reactivity increases, and in non-metal due to increase in size, because it's about the lose electron and or gain electron. Okay, so when some questions asked in your board, then keep in mind that the question is all about what is about the metals and non-metals. Okay, if we distinguish between the metals and non-metals, you can completely solve the questions. Okay, and in the last, that is oxides, that is nature of oxides. The simply nature of oxides, when we go top to bottom in a periodic table, that it remains the same, because when we go top to bottom, that is react with oxygen, and it combine and it forms an oxide, and the nature of oxides remains the same due to neutral in nature. Thank you so much. I hope all things are very clear to you. This is the last part. I hope you studied very well. Thank you so much.